Good morning. So today we're going to talk about abstractions. It's so let's start from scratch and find out what the need for abstractions is. Anyway, so I have my Jupyter notebook on. I'll explain what a Jupyter notebook is sometime later, but it helps me to produce a tutorial and post online so that you can take a look at it. So let me start. Now, let's say in Python, you want to do 1 plus 1, shift enter, you see you get 2. If that was all you wanted to do in programming, then you're done. A Python 1 plus 1 programmer. Hey. But in case you want to do a little more, let's look for a simple example. Let's say you want to find out when you can get a driver's license. So in Python, you use hash for comments. It means that Python is going to ignore the line driver's license. So let's talk about driver's licenses. Enter so that's the header. So let's say, how long will it be before I get my first driver's license? Not me, of course, but somebody else, maybe someone younger than 18. In most countries that I know of, 18 is the legal age for driving, of getting a driver's license. Usually you learn how to drive much earlier. And so let's say, how many years before I get my driver's license? Let's say 18 minus, assuming you're 10 years old, 18 minus 10. Yay, we get it. So in 8 years, you should be able to get your driver's license. But let's say you know your date of birth and not exactly your age. So first, you subtract the current date from your date of birth. Then you will subtract whatever you get from 18 to get how long it will take. So let's say your date of birth is 2010. So it will be 18 minus 2018, which is today's year, 2010. Yes, excellent. So we still, oh, wait. That means 2010, that means you're 8 years old. Oh, sorry. Let's say, uh, okay, yeah, 8 years old. So you have 10 years. But assuming you come you do this calculation and you take it to your dad or your mom and say, hey, see what I've done, and you just show it to them without any explanation. They'll be like, okay, you did 18 minus 2018 minus 2010 and you got 10. Yeah, well, why would you do this? And so let's take a different tack. Let's say you want the code to be self-explanatory. You want it to be easier to read. So let's say we say age equals 2018 minus 2010. Then let's say, oh no, I didn't want to do that. Let me remove this. I want to put everything in the same place. Then you say current year equals. Oh, okay. So I think we're even doing this wrong. Let's start with current year. Current year equals 2018. Age is this. Current year is 2018. Driver's license. Shush, I always make this mistake. Wait for license equals the age for, that's 18 minus age. Okay, I don't think we need current here. Let's just do this one. So if you go and show your parents this, let's run this one. So let's run this. Let's run this one. Okay, it doesn't give us anything. So wait, let's just print. Print wait for license. Okay, so it gives us 10. You see, so there's a difference between dates. There's more than one difference. But if you just take this and show it to your parents or show it to somebody, they really don't know what you're talking about. But if you do this, you say age is 2018 minus 2010. Wait for license is 18 minus age. Print wait for license. It's sort of obvious what you're trying to do. That you are printing how long it will take for you to wait for license. Because, this is like expo. So you can see clearly that writing something like this is much more readable than writing something like this. Now, what we're doing differently here is that we're giving names to certain data, which is generally what we do in real life. For instance, if you want to describe a car, you just say, oh, it's a car. If you want to you talk about a car, you just say it's a car. And when you say it's a car, everybody that knows what a car is will understand that, oh, it has tires, it has a steering wheel, it has an engine. And if you talk about engines, it's okay, it has a, I don't know what's in an engine. So, but you understand what I mean. So these things are actually called abstractions. They make it easier for us to think about. They make it easier for us to think about things in real life. Let me abstractions. I'll name this notebook abstractions. Okay. So let's use another example. This driver's license. Another example is sweets. Sweets. So let's say you buy 10 sweets and you give it to 5 children. So how many sweets will each child have? Assuming there's no bully who will take like 9 of the sweets and give them one to share. But we'll just simply say 10 divided by 5. If you run this, you get 2, right? You get 2.0, yeah, but it's 2. So let us now assume that each child is asked to return half of the total sweets that they have. So how many sweets will each child return? First, we know each child got 10 divided by 5. Then for them to return half, the amount they're going to return will now be this divided by 2. So if we run it, we get 1. So each child will return 1 sweet. But again, if we come back, like this example, this doesn't have much meaning to us. It's very abstract. But let's say we give some names. We'll say total sweets. Sweets equal 10. Sweets per child equal, number of children. Let's say number of children. Kids equal 5. So we can now calculate sweets per kid to be total sweets divided by number of kids. Then let's print it out. Print sweets per kid. Boom. And we get 2. Then let's say each kid returns 1 sweet, right? We can now say return sweets returned, sweets returned, not one sweet, I mean half the total number that the kid got, equals sweets per kid divided by 2. So we can print sweets per kid, and we can print sweets returned. Boom. And we get 1. So we're actually doing exact same thing that we did previously, but we're doing it in a way that is easier to read. Right now we're talking about sweets. It might be easier to do it this first way because it's just one line instead of taking so many lines to describe something that is very simple. But imagine that you have like in real life, imagine that you want to describe a car. It is much easier to say car than to describe all the composing parts, because you say, oh, it has a steering wheel. But a steering wheel also is not a fundamental, like element or something. You have to describe the steering wheel. So by the time you start describing, you'll spend the rest of your life describing one car. And so that's why that's what the power of abstraction is. The power of abstraction is to enable us to talk about concepts or complex objects. Okay, so let's in real life also we have it's not only objects that we describe with a name, that we give a name to. We also give names to like actions. For instance, let's say someone is running. Running, or to run, is an action, it's a verb, and we have a name for it. So, and we have an equivalent in Python also. For instance, let's say we want to add numbers together. We can name that action of adding, which is irrespective of the numbers that you are actually adding together. Wait, I think I need to explain. So another example of an abstraction in real life is construction or building. For instance, let's say a road. A road is an object, and we have a name for a road. Then we also have a name for making a road, that's building a road. So let's say you can call it build or construction. So the word build or construction doesn't have to be used for roads alone. You can build houses, you can even build software. So the abstraction for actions in Python is called a function. Let us try and get an example where we need an abstraction. Then we can. So let's talk about functions. Or before we talk about functions, let's even see how functions are going to be useful for us. So we're going back to our first example, driver's license. So for driver's license, we have this construct that we said is really nice to use. We have the age, we define the age, the wait for license, time, number of years you need to wait for license, then we print it out. So it's really very simple. But let's say your age is different. Let's say your age is, or your date of birth is different, really. So let's even make this thing a little more readable. So back, let me just call it driver's license. Driver's license continued. So so let's say instead of just saying your age is this, we'll start from saying your date of birth, or this year equals 2018, date of birth equals, Oh, year of birth, really, 2010, right? So your age will be, let me put year of birth, year of birth. So your age will now be this year minus year of birth. This year minus year of of birth, right? Then your weight for license will be 18. Let's just assume 18 is the normal age to get a driver's license. So it will be 18 minus age. So we let's see. Oops, there is a problem. Oh, this year, sorry. Now in giving names, we have rules in Python. You can't put a space in a name, right? You have to it has to be a whole word, no spaces in names. And there are other things you can put in names. So let me just tell you what you can put in names. You can use letters, you can use underscore, you can use numbers, but you can't use numbers as the first. You can't say one this year, right? If you try it, it will tell you, you have a syntax, invalid syntax. You can see it. So you can use one. You can use a letter at the beginning, or you can use an underscore at the beginning. So just try to, the rules are a bit complex, but if you just remember that, use letters and underscores. It's very easy for you. You can use numbers, but I don't know why would you want to use numbers. I don't know. Okay, so let's say we use this year as 2018. If we try it now, you see it works. So this we're actually using more lines of code, but we are making it more readable, because if you show this to your parents, you just say, "Oh, this year is 2018. Yeah. Year of birth is 2010. Okay. Age is this year minus year of birth. It makes sense. Weight for license is 18 minus age. Yeah, it makes a lot of sense. It's easy for someone to read this. And so now, but this is your own, is calculation for yourself alone. So this is how to calculate how long you will wait for your license. Well, how long will your brother or how long will your sister wait for his or her own license? The year of birth is usually different, except you're twins. As we are not twins. And so we'll have to do this same calculation for your, let me just put sister. Let's assume you're older than your sister. So it's not very likely, but well, let's see. And we run this. You see, we get your sister needs to wait for 12 years because her own year of birth is 2012. So she has to wait for 12 years before she gets her license. Shit. Okay, sorry. Now, but you can see how clumsy this will get. When you're calculating how long all the children in your family, your extended family, will have to wait for them to get their driver's licenses. So let us say we give a name to the action of getting the year, getting how long you wait for your driver's license. Let's say we give a name to that action. Maybe we can now use the action over and over again. In Python, giving names to actions is called functions. They're called functions, and this is how we do it. You use def. Then let's give it a name. We'll say years to wait. Years to wait. Then we need to open and close brackets. Then what we do is so we will just copy everything here and put here. Boom. Then everything inside a function will need to be indented. That's another rule in Python, indentation. So we've talked about two rules. Now we've talked about the naming of anything. You use what do you call it? You use letters or underscore. Now we're saying about, when you define a function, you need to indent. You use a colon here. This is called the header of the function. You first use def, you give it a name, you open and close brackets, you put a colon, then all the things that are the functionality of that function or the actions that should take place in that function will be indented. 4 spaces, please. You can use 4 spaces, you can use tabs. So you can even use 2 spaces if you like, but just do 4 spaces, please. Now you indent and you put all these things here. Now let's even run it and see what happens. I run, boom. Oh, nothing happens. Yes. So when you define a function, you are only naming a kind of functionality. You are naming an action. You need to carry out the action before you get anything. So to carry out the action, you call the name, you open and close the brackets. Aha, can you see we get 12? But the whole idea of making this function is so that we can get the get this abstraction of calculating how many years to wait for a license. It's not just calculating for your sister. This one just calculates for your sister. So let's remove a few things. Let's say this year. Let's leave this year. Let's say year of birth, right? Let's put the year of birth. Let's make it like something you can vary. And things that you can vary are things that you pass into the function. So let's make this function again. Is a second version of the function. Let me just put. I'll copy it and paste here. Years to wait. I'll put version 2. Right. So in this case, I'll put the year of birth out in this year of birth here, and I'll remove it from here so that so it's years to wait v2, right? So I'll remove it from here. So you pass it in. Let's even see how you can pass things into functions. So if I call years to wait v2 means version 2, I cannot just make it empty right now, because if I make it empty, it will give me an error. Years to wait v2 missing one required positional argument, years of birth, because in the definition here, we said it should take in the years of birth. So the year of birth. So year of birth, let's say we put 2012 and we try it again. Yes, it gives us 12. Now, if we try this again, let me just copy and paste instead of typing because I'm lazy. Now, in your own case, 2010, you see it's 10 years to wait. Now, let's even try for your cousin. Let's try for your cousin. Your cousin is very old. Your cousin was born in 2007. Ooh, your cousin hasn't said, okay, let's say your cousin is even older than that, 2002. And your cousin will get a driver's license in 2 years. Awesome. Okay, so you understand how functions have simplified our code, right? It's an abstraction. You give a name to some kind of functionality that you can apply to different objects. Like you can apply it to yourself, to your sister, to your cousin. So it depends on the kind of functionality you want to. Okay, so let's make this a little more friendly. Let's call the function get your license. Then you pass in your year of birth, and you get a response out. So let's see. Let's call it get license. You pass in your year of birth. Then we still use this year. This underscore year equals 2018. Age equals this year minus year of birth. Then wait for license. I shall just copy and paste it. License equals 18 minus age, right? Now, let's do something different here. Because I should know.